everyone, welcome to another session of Dr. Spotfire. We believe that learning is not driven by answers, but by questions. So every session, we pick up questions that you post on community and walk through solutions of them. But throughout the session, if you have any comments, feedback, follow-ups, we are very happy to hear them on chat. I'm Divya Jyoti Rajdev, or DJ. I run the technical Q&A part. Ninad Save is my equivalent, and he runs the strategy. We work with different teams so that we're able to get you the best from all the new content out there. Vinod and Robert help with the post-processing, and Anna is the campaign manager. Today's featured speaker is Peter Shaw. You might recognize him from the many templates he has on the Exchange and also from the excellent geoanalytics page that he maintains. Today, he's going to be talking about self-organizing maps. It's a data exploration technique that's similar to the similarity and clustering techniques, but it's a bit more explainable, so we'll get into the details of that. Over to you, Peter.
Great, thanks, DJ. Let me share my screen. All right, yeah, well, thanks. So, yeah, I'm Peter Shaw. I'll be talking about self-organizing maps, especially with Spotfire. And rather than just jumping in off the deep end, I thought I would kind of work my way into it a little bit, kind of more gradually. So I'm going to be talking about, if you are faced with a complex data set, for example, that you want to understand better, perhaps you have some data you've just received, or you want to really understand what's in the data set. You want to kind of dive in and essentially we want to look for some patterns. Basically, if you have a complex data set, your brain can understand a tiny fraction of that. So there's a number of ways of, dimension reduction or looking for patterns or clusters, whatever. So that's what the goal is of this thing. Self-organizing maps isn't the only answer. It's one of quite a large family of things. So the sort of presentation I'll be going through is showing a couple examples of this, like sort of a real example and a kind of a toy example to kind of walk through things. And then, so some of the early tools would be just straight up visualization of scatter plots and Spotfire. Just what do you have to work with to show some simple things? And of course, the linking aspect in Spotfire is fantastic for that, because if you see something in one plot, you can say, all right, so what does that mean linked to another plot, right? So then the next level up in complexity is the out-of-the-box k-means clustering. There's also a template we've got in the Spotfire Exchange. I'll be showing that that you can use, and that is used for, again, trying to make some sense of this high-dimensional data. So you have high-dimensional data, and k-means clusters is a fantastic way of simplifying that for organizing the data into discrete groups. Now, in practice, you might be a retailer, you might have some customers, you might want to do some customer segmentation. So k-means clustering is a way of segmenting your customers into groups. You might find people who are, shopping for the beach in the summertime, or shopping for the kids back to school, or, fall, buying a coat in the fall, or whatever. So there might be some discrete and very different but distinct kind of clusters of activity. Or in manufacturing, you might have some machines that are doing making stuff, and that the data might represent the state of the machines at different time points. So the machines might have different states. So it might be, in a baking stage, or warming up, or it might be operating or spinning down. So each of those things might be characterized by a certain sort of constellation measurement. So you might be using that to identify which state your system is, or if you have like a city, looking at the traffic patterns in the city, during a sports event, some highways might be clogged up. So a lot of ways in which clustering is quite useful. So this will get to the self-organizing maps, and I'll be spending some time on what these are, how they're useful. So to jump right in, I guess I'll look at the complex data. Actually, I should talk about where this came from. This is This is some awesome data from the World Bank. They maintain quite a deep collection of data. They've got this open data initiative, and they've got this data catalog. You can go through and evaluate the data. So they have a lot of very interesting data for countries around the world. I'll be using this as my example of a complex data set. So if I actually just look at the data itself, I've got a lot of different columns here, a zillion different columns, and the data themselves, there's some gaps, there's quite a variation in, some of the columns are very large numerically, like, thousands, others are percentages that go from 0 to 100. Some of them are rates, they might be negative. So there's, your typical data things, blank data, different scales and stuff. But to use some of the Spotfire basic tools here. So I've collected a series of these indicators. In fact, there's like a lot more on the World Bank data set, and they actually are time series too. But if I choose one of these indicators on the left-hand side, the map will respond on the right-hand side, right? So I've got this linked, so I can just basically say, okay, here's a bunch of really interesting looking indicators. In this case, I've selected the internet use per 100 people. So US and Northern Europe have a fairly high value for this, and parts of Africa less so. If I look at the rural population indicator, you can see some parts of Africa have a fairly high value. So, you can spend a lot of time just like looking over these indicators on the map and just having a great time. But this, at the end of the day, is a single variable. So it's kind of fun, but you're just looking at a single variable. The purpose is you're trying to understand like all these variables here, and it's a lot of work to go through one at a time and then remember, oh yeah, this other one had a pen over here. So you can't remember all these things at the same time. The next level up is looking at two variables. So if I've got the scatter plot here, upper right-hand side, and the same variables, but now I can choose, which is the variable that control the x and the y axes. And if I now highlight these little groups here, I might see parts of the map kind of light up. It's a little hard to see because the map's a bit small, but I'm seeing parts of the map light up. And then if I, look at different variables here, I might see other little areas of interest. And this is fun too, so you can kind of flip through these guys pretty well. And again, you're looking for little parts that clump together, and that's great too, because that's the next level up. But what you'd like to do is say, okay, if I choose two completely different variables and I see a clump, well, is that the same clump as before, or maybe that's a different clump? So again, this is the early exploration part. So what I thought I'd do is basically, that's kind of setting the stage. Now, what I thought I'd do is kind of introduce some very simple data. So my approach to things, if I don't understand it very well, is I like to start by simplifying things greatly. So I have some data that I made up that is clustered, right? So it's basically X, Y, and Z. And if I make some plots, some just basic two-dimensional plots of these, I can look at, Y versus X, Z versus X, and, Y versus Z. So, and as you can see, the data are clustered. So if I say, oh, here's a likely looking cluster, and I kind of highlight this, I can see that it's the same as that cluster, and it shows up down here. So you can, use this Spotfire linking capabilities to explore this. And, if you didn't know that, you might say, oh, here's the isolated cluster. Maybe it's the same as this isolated cluster. Actually, it's not, because they're different clusters, right? So that one is a bit hard to see in this orientation because you're looking, the projection is not suitable for distinguishing these two in this plot, but you need a good projection to see where these are. So it's kind of the next level up. And this is a fairly common practice to use a bunch of these plots. You can make an entire matrix, a scatter plot matrix. if you have many, many variables, you can plot each one against each other one, get a fairly dazzling matrix there. That's quite useful. Often it can be useful to plot these, straight up in 3 dimensions, because I have 3 dimensions here. So here's the same data, but now in 3 dimensions. So, and this is, I guess DJ tells me this is more familiar in some industries than others. So I can kind of, scoot this around and look at these and say, yeah, these are actually, 5 discrete clusters. So, and the purpose of this plot is you'd say, okay, if I crank this around and find the right orientation to look at, some of these rotation angles is really good for actually seeing each cluster quite separately. So that's fantastic. All right, to carry on.
If I just comment on that very quickly. So for example, if you're working in manufacturing and you have yields, then you would assume that your parameters that have high yield would respectively clump together in higher dimension would be a cluster, and everything else would either be an outlier or be some other setting for a different type of yield or a different type of calibration. So I've seen it in manufacturing. I have seen it quite often in when you're working with marine, aquatic environment and aqua farming. Then again the parameters over there would be look like this. Go ahead, Peter.
Yeah, thanks. And that's a good point because in any industry, one clump here might represent, these are people shopping for the kids back to school. They're shopping for school supplies or whatever. These are people shopping for, chips and stuff, getting ready for the big sports game on TV. They're stocking up on snacks and whatever. These are people going to the beach. There's different things you can, different behaviors of people, or it might be different states of a machine or whatever. It might be in a city, traffic patterns. This could represent a traffic pattern when a sports event gets out. This could be one when, during typical rush hour. There's a lot of ways you're looking for behaviors of complex systems. And you're just trying to wrap your head around understanding some commonalities in the data. And this is just one of many tools for doing this. If I jump ahead to the out-of-the-box Spotfire k-means clustering, I've got this set up. So the left-hand side is the out-of-the-box k-means clustering with the X, Y, and Z variables. And I'm getting there by this tools menu down to the k-means clustering dialog, and I can actually specify how many clusters to use. So I guess there's 5 clusters here. So if I choose 5 clusters, it'll kind of regroup and form 5 clusters. These are color coded by the cluster identifier. So I've got 5 clusters here. And this poor little cluster up to the upper right-hand side, I guess, gets scattered across many of these cluster identifiers. So the thing about k-means clustering is it's a very easy thing to understand. It's a way of the machine learning, is saying, hey, these are like the clusters I've found. I found 5 clusters. Here they are. They're kind of in a bucket, so it doesn't tell you much beyond, okay, here's all the elements in cluster number 4, which are, I guess, yellow there. It doesn't really distinguish. It's not very nuanced, right? So it's like everything inside here is the same. Although in this presentation, obviously in Spotfire, you can look at some of the subsections within there. So this is a quite nice presentation. Other ones, you have to do a bit more work to pull out some of the parts that are separate, but you actually can see some parts within there that are separate. But in general, the k-means clustering by itself as a tool doesn't tell you any nuanced information about what happens within the cluster. All the elements within that cluster are treated as being the same. So, if you're trying to simplify the data, that's great. It can be a bit of a blocker there too. Let's jump on to the self-organizing map section. And this, by contrast, takes a bit more thought. And honestly, when I first saw this in textbooks and stuff, I was like, I don't understand this at all. But the Spotfire, using this in Spotfire helped me understand what's going on. So the way this works, let me actually jump to, there's a really nice Wikipedia explanation about this. If you look this up in Wikipedia, you see a nice article about this, a lot of cool stuff. The one cartoon that I really, really like is this cartoon here, which basically represents the data in purple. You got this weird, like the clusters I've just been showing you guys. And this kind of crumpled piece of paper here is the map. So the self-organizing map, the map part represents you're mapping your data in all this glorious high dimensionality to this two-dimensional manifold here. So and then the manifold is kind of crumpled up. So, and the process of computation for the self-organized map is an iterative procedure shown here. But the result is you kind of fold your end result kind of manifold around and into your data in some way that best captures all the variations. And then when you're done, you've got this, you've kind of captured the variations onto your map there. So that's, in a nutshell, what this is. So here's my data, and here's the map. And so each of these little symbols here represents a point on the map. So treat this left-hand side as a continuous piece of fabric, if you will. It's got X and Y dimensions, and on each of these little symbols here, focus on the middle point, which happens to be green. That's a little unfortunate. Treat the middle part as just a neutral middle point here. So this is actually on a grid, so there's nothing significant about any of these grid points themselves. They just represent a stake in the ground on this manifold. And by the way, I could have actually used a finer or a coarser mesh here. So the mesh itself isn't important, just the variations in the mesh. So at one of these points, let's say this point right here, it's got a big blue. So the distance out from that center point tells you this one has a fairly decent green component, a fairly decent blue component. The red one is like totally non-existent. And if I highlight that, it shows me, I guess it's back towards where the red component is basically 0. So the lengths of these little sticks here represents the size of the thing. By the way, this plot is a garden variety Spotfire scatter plot with connected lines, and the trick is that the data that's driving this comes from a care data function that I wrote that carefully arranges the results of the self-organizing map into a result that can be, picked up and shown in Spotfire. DJ encouraged me to show the essential parts of the code here. So the SOM, the self-organizing map code, this is in the self-organizing map was kind of figured out by, I guess, Cahonen was one of the early people who advocated this and kind of worked this out. Brian Ripley included this in the class R package. So this is from the class package by Brian Ripley. There's a batch SOM call. Fairly simple calls here. This sequence of numbers here is because it's an iterative method. This kind of tells you how quickly to converge on, the final values. There's nothing really magic about that, and that gives you this kind of fabric here. And somewhere in there, there's some settings for how many X and Y elements to show in the fabric. That basically gives you just these stakes in the ground, and from here, I use key nearest neighbors to actually collect and find. So for this stake in the ground, what are the points that are nearest this? I seem to be managing to choose all the ones that don't show up very well, but you can see that's kind of lining up over there. By the way, this is set up that if I want to select this piece right here, it doesn't matter which of these I select, they're all kind of the same, so I can select all of them or none of them or just one of them. So I can be a little bit sloppy if I'm going to be, going through here and looking for interesting parts of this map to highlight. I don't have to be completely careful about how I do this. So that's how that works. it might be useful to say, to go backwards. So if I go from the data to the map, what I find is that each of these clusters does actually map. So this is the map, right? So this part maps to this little row here of the self-organizing map display. If I choose a different little cluster, I'll get a different area. But what you'll notice is that, you know, you can't look at this map and say, oh, these are the clearly defined 3 or 4 or 5 clusters. But in general, the areas will be contiguous. So think of this as kind of a continuous variation. So these are all the points in that cluster, but you know the cluster does have some extent here. It's not just a single point; it has some extent in X, Y, and Z. So these parts down here, you know, there's some little variations. So like the upper right-hand side, this green thing is larger than the red over here. They're more equal size. So that's the kind of more subtle, nuanced thing I was kind of mentioning. Plus, what's kind of cool is that this one is actually kind of close to this one. These are in 2 separate kind of clusters, but hey, guess what? You know, they're actually pretty close to each other. So even though your eye says, yeah, these are different clusters, in fact, this tells you, well, yeah, they are, but these parts are actually kind of similar to each other. So you can kind of look for some similarities there. So I find the self-organizing map, it takes a bit more mental investment to kind of buy into what this means, but it's really quite valuable, I think, because it lets you say, okay, here's my data, here it is in the map, and I can then go out and say, well, okay, so here's that thing, so maybe this one over here might be kind of similar. Actually, it isn't, but you know, I mean, it does its best to try to find things which are similar to each other. So that's how that goes. All right, let's go back to the World Bank data because that needs to carry on with this discussion here. Let me go to my, so let me actually, did I talk about it? I did talk about it. So there's we have a template on the Exchange which does clustering. So I thought I'd talk about the clustering first with this Exchange component, and then onto this self-organizing map. So on the Exchange, there's we have a template, and I'm just showing the that toy data with the template for doing clustering. And the way, let me actually just go to the Exchange itself. So go back to here. So here's our Tibco community, and if I go to the just go, so here's the Exchange link, and this basically has all these contributed Spotfire components. This one, apparently the thumbnail has gone missing, but here's the one for clustering with variable importance data function. And as of a few days ago, as well as the downloads, you can just download it yourself, or you can actually just immediately go to this cloud version. So this is actually live up in the cloud. And if I, so here's my world indicator data again. So it's the same data set, but it's actually kind of a smaller collection of data. But this is actually like live in the cloud. You can go there right now yourself and play around with this. And so this is still the cluster analysis. The way this works is that you select with the slider how many clusters to look for, and just chose one for some reason. Let's choose 3, for example, and they'll basically find the clusters for you, color code them on the map. And the neat thing about this one is that, as well as the clustering, it'll find the top 2 variables. So I've selected like all these variables here, and out of all these variables, it's found the top 2, which is the depth of credit information and the cost to do business here. So these are the 2 which best allow you to distinguish the clusters. So that's where that is. And that's on the Exchange. The self-organizing mapping isn't, but let's show you the self-organizing map with this World Bank data. So And so okay, so the way this is set up is I have these the variables on the left. This is the same group of variables I showed you before, and whenever I select, 2 or 3 or 4, it'll like immediately use these to produce this varying map down below, and I can actually select different regions of this thing and see that these countries have some similarities compared, if I look at the things I've just selected, infant mortality, population in 65 and above, population growth, and population age 0 to 14. This little nook up here in the upper right-hand side, Chile and Australia and New Zealand are somewhat similar. I think let me actually select the ones I was, look at the internet. I think population 0 to 14 and the rural population. I kind of looked at these as a way of showing myself how this works. So I selected these 3 variables: the internet usage, rate of usage, I guess, the population, young population, and the rural population. And here are the 3 variables as shown on the map. The internet usage is the green. So in the upper right-hand side, these countries have fairly high internet usage, and compared to the rest of the countries, their population 0 to 14 percentage and the rural population is fairly small compared to others. So you can see this looks like Northern Europe and US and Canada. Other ones, if you look at the areas with very low internet usage and maybe a high rural population, it shows you Central Africa, for example. And, you begin to see these patterns of countries that are sort of similar in these metrics. And what you can do is you can say, okay, if I start with a country like the US, and here it is right there, and you can say, okay, show me the other countries that are similar. You can kind of see those similarities. By the way, again, there's no great significance to the actual group here. I'm actually trying to highlight a sort of a region. So it's sort of the same as highlighting kind of a nearby region of these things. And because the mapping is not uniform, it's quite possible that some areas of this display on the left, some parts might have a great density of countries, and other ones might have a fairly low density. So actually, it's still a country, but hard to see because they're actually small in geographical size here. But some of these might have a lot more countries than others. So just keep in mind that it's not uniform. But what you can do also is you can say, I might want to look at just grab a few variables of interest here. Just grab a few of these, and you get these fairly wild-looking I got 5 here, and you get this fairly wild-looking presentations here. And there's actually now some quite striking variations across here. What you can do is you can look for, so this one might have fairly low diabetes but high internet usage, for example, and see where those are. That's kind of interesting. This one's sort of nearby. So it's quite interesting that these are kind of geographically very similar to each other. So that's, well, that's kind of interesting. You can also go backwards and say, if you live in Australia, for example, here you are there. Who are your countries that are kind of similar to you? Australia, Lithuania, for example, and some other ones there. Or you might choose the US. Here's the US right there, and look for some similarities. So you can spend a lot of time. And again, this is what I was talking about the nuanced kind of methodology. So because this is a continuous variable, you can say, these are different points in this map, but these two things kind of look kind of similar. And as you go up and down, left and right, they're actually varying somewhat slowly. And as you get more variables to look at and more interesting variations, it might be worthwhile at that point to fill in these gaps with more points. I didn't do it in this case because there's only so many countries in the world, but if you have a lot more data points to work with, it might be quite useful and quite informative to really create a very detailed, richly sampled fabric here to explore. So in a nutshell, I found the self-organizing map quite complementary. I mean, there's a lot of ways to look for patterns in data. There's k-means clustering, there's principal component analysis, multidimensional scaling. There's a ton of different ways of just dimension reduction to understand, take a complex high-dimensional data set and simplify it so you can understand it, what's going on. And I find the self-organizing map, especially with the dynamic linking between plots and Spotfire, is a fantastic way of understanding a complex data set. So I guess that's a good point to stop there.
All right, thank you, Peter.
Presentation. Yep.
That was absolutely smashing. I really enjoyed how you could visually see what was greater and what was lesser in terms of the dimensions and how it impacted the overall flow. I'm going to segue to another page. If you enjoy geoanalytics, I encourage you to check out the Tibco Spotfire location analytics page that Peter maintains. I've just sent you the link on chat. It has this amazing gallery of all the different ways you can use maps and everything that you can do with geoanalytics. And when you click on it, it'll basically take you to more information about, where to find resources for that. So you can just go through this page and it's quite interesting. All right, moving on after that amazing session to our usual Q&A. If anyone has questions for Peter or for the session, post them on chat and Q&A. We are monitoring it and we'll be picking it up. For our Q&A session, the way that we like to do things is that if you post your question on answers and you tag it with hashtag Dr. Spotfire, we pick it up if it's unanswered and we'll walk through it over here. You can also email us your question only if it has some sensitive data that you don't quite want to post on the community website, and the email address is drspotfire@tibco.com. Then just a couple of pages that are very, very useful. So there's the Essential Resources page that is a simple list format of all the different Tibco resources and how it works. And then there's also the Customer Success Management page, which is more like a newsletter style page about, what are the new articles and what's the latest. So these are, again, just great resources to have bookmarked if you need help with Spotfire. Just 1 second, I have to plug in my laptop or we're going to run out of battery in the middle of the session. Okay, all good now. So let's start with our questions for the week. The first one is basically how to loop through the columns in a table and get their names. I am posting all of the links and resources that I discuss on chat, so make sure that you're active and you're grabbing whichever ones you find useful and you need to. Now, this question basically uses this data set. Over here, you can see that I have 3 columns, A, B, and D, and column 1, 4 columns, out of which column 1 and D are empty. So what I want to do is I just want to grab the names of column 1 and D, and this is what it will look like. So the easiest way to accomplish this is by using data functions. You could use expression functions, but giving it input would be a little bit more difficult since the way that expression functions typically work is you would need columns for that. So data functions are just the simplest way to go about it. The code is very simple. So you take the output, and this is a document property, such that you look at the names of your input data set, and which index of the names are, all of them is empty, then you just grab that index and you paste it together with the syntax. So every time I answer a question, I make sure that I post the solution on community as well. So if you were to go to community, you would find my answer already there. And this is also going to be summarized in the YouTube video and the Dr. Spotfire summary page. Just to walk you around the data function a little bit. A simple one-line data function takes the input as a table and gives the output as a value. That value is a document property that we set up in this text area. So if I go in and edit this, you can see that it's a string value and it comes out. Now, this is something that most people don't know about. So if you right-click and do format control, you get a bunch of very nice formatting options for your text area. So I could like change the color and make it bold and so on. So it's just a nice thing that I like to show people. So this is from when I run the code last. So let's go in and modify the code a little bit and run it again. So instead of like, a comma to separate it, let me actually give it a semicolon and a space. And you can see that this changed a little bit. So it's just standard format. If you wanted to get the output as just, names of columns instead of like one string, because right now I'm using paste, then if you just avoid the paste and use the rest of the code, then it will give you just a list of names. I am pasting two resources that are related to data functions. How we've gone through several times on Dr. Spotfire on how to set up data functions. So I won't be doing that again, but for those of you who have just recently started following us, these are a couple of resources that help you get familiar with and get the most out of your data functions. The next question that I have is actually something that was residual from the last session. So I'd said I'd answer this in the last session, but I wasn't able to. So here the user says that they want to work with multiple input tables in a TER-R script, and they're not sure how to do that. They're wondering if they can programmatically reference a table. So the answer is actually quite simple. If I write a data table, if I write a TER script, then I can actually take the input as multiple data tables. So I'm just going to show you an example. So if I have input 1, if I have input 2, I can now right-click both of them, call it an input parameter, call it a table, and say that all my data types are allowed. Otherwise, it will try and type check and make sure that I only get the data types that I select. So again, I'll do the same thing, call it a table, say that all of them are allowed, click OK. And now with these two tables, I can do like whatever I want. So I can create a duplicate. Input 1 takes input 1 and just create a linked duplicate of that table. So additionally, when I was providing it the inputs, you saw that my input could actually be a document property, or it could be a single column. Now, when your data table goes into a data function, I see a lot of people writing code like this. So for example, if I have input 1, I have a lot of people typecasting it as a data frame. Now, this is something that you don't need to do because Spotfire just does it. So if I show you an example of that, let's go back to the question that we did previously, and let's define output 2 as class of input 1. Actually, it's just input. And I'm going to define it as an output parameter, which is a value. Okay, I'm going to save this, close, edit parameters, because now I need to set up that secondary parameter. Call it a document property, create a new document property, and let's call it class. Click OK, okay, and let's refresh it. And now if I go to edit document properties, you will see that the property that I just created has the value data frame. So any table, when it goes through to a data function, it's just automatically a data frame. You don't need to, again, classify it as a data frame. Now, this is a question that I'm very excited about covering. Glad to see that you guys are using the community exchange and you're actually downloading and trying out these functions by yourself. So the user has trouble implementing heat map for Tibco Spotfire. It made it a little bit difficult for folks to understand what they were referring to, because technically it's not a tear package, it's a template. So because there's also an open source R package called heat map, and in Spotfire, since we have our own heat map, we don't support that graphics package. So it was a little bit difficult to understand this. So when you're posting, just make sure that you provide links, you provide examples, you provide data, and that will really speed things up. To show you where this data function exists, it's on the exchange and you can download it and try. In fact, you don't even need to download it. There's a cloud version, which is very exciting. It just takes you to the DXP that's hosted on the cloud, and you can, play around with it, see it update. This is the one with crazy colors. This is the one without crazy colors. Now, the user had a problem in replacing the data within that data table. So I'm going to walk through how to replace the data table in this Exchange template. So I've already downloaded the Exchange template, and you can see that I've unzipped it. It comes with a few different documents. So let's just run over to the DXP. That's what we're going to be working with primarily. And just to show you how this works is it has analysis data. This is the primary data table, which has latitude, longitude, and value. And we're going to be working with, just, you can have more data, but this is what your data function actually needs for it to go through and do its job. And then you have some tuning parameters, which is smoothing level for heat maps. So if you increase it or decrease it, your contours and your grid, the way it looks, that changes. So now, these are some reference informations and how-to help that you will need. But let's get started with replacing our data table. This is the starting point with all the points plotted. So I'm going to go to File, Replace Data Table, Analysis Data, and I'm going to replace it with Marine CSV sample. This is the data that I downloaded from NOAA website. I closed the link, but it should basically be this. Oops. Yeah, I think this is the one that I have. So now when I say, okay, let's grab this data table, you can see that it gives me a nice little preview of it, and I can see that a lot of it is empty. So I'm just going to look out for columns where I can sort of see some data. So there's dew point temperature, there's wind direction, wind speed, total cloud, air temperature, sea level pressure, etc. So I'm going to say okay, but as we saw, I don't actually need all those columns. I just literally need 3 columns. So I'm going to say, all right, I'm going to add a transformation. I think I did this a little too quickly, but under your replace data table, you also have options to do transformations. So you can change the data type, you can pivot or unpivot. So I'm using the transformation exclude columns, and I am just looking for sea level pressure. So I'm going to ignore all the other columns. Now, what happens if I don't ignore all of them? Let's say you do have data with more columns. So I'm leaving one column in there just to show you that it's perfectly fine to have more data. Now, this is a transformation. This is what I was talking about. So there's a bunch of different transformations. They're very handy. You can use them to replace multiple values. When you click OK, Spotfire figured out that your latitude and longitude match to each other, but it doesn't quite know what your value column should be. So for my value column, I'm going to match it to the sea level pressure. That's what I want to use. Then I say OK, and it replaces my table. And then when I go to my heat map, this is a very useful functionality in Spotfire data functions that was recently introduced, which shows you if you put out any print statements inside your script, this is going to show you that as warning. So I have some debug output, but everything looks fine. It just has something to do with how the inputs and outputs were processed. So I'm going to auto zoom, and the moment I auto zoom, you can kind of see that, I do have my data, but my data is just not where I expected it to be. So this is a very nice single click auto zoom functionality. So let's go and change our smoothing level and see how it impacts it. Clearly, I should have chosen data that is a bit more representative. But I had a geo data point, so I said, okay, why not? Let's just try that. You would typically be using a data set that's a little bit more amenable to some of these transformations. But you can sort of see that we have these bands and it's kind of working out. So I'm going to go ahead and go to my heat map and go to my layer settings and change my colors a little bit. So now I have my max at something like a red, and let's put in another one that's like a yellow, and let's put this as like so the DXP works, the data replacement works. The thing that I can guess from the user's problem is that maybe they didn't match the column, or maybe when they were inserting, they didn't select that column to insert, So there was a little bit of a mismatch, but in terms of how the DXP functions, you get a perfectly good output. Let's go to the cloud version because I want to show you something around how it's been set up. So over here, oh, this is not in edit control. So I'm going to go ahead and undo my replace table because I really want to show you how to change some of the colors. It really creates a very big visual impact when you're working with geo data. I'm just undoing all of my steps. It'll be easier to just open it again. This Spotfire can communicate across your geo layers. So if you look at it, I've got contours, I've got heat map, and I've got major contours, and all of them have their own color settings. So right now I'm at the heat map color setting. Heat map properties And you can see that the center is white. Let's go ahead and change that a little bit. So I'm going to start with like yellow and move to an orange and move to a red and move to a brown and a black. And if I go to appearance and I reduce the transparency, you can now see how the look and feel is almost completely transformed. This is like a much more intense, luminescent color scheme. So you can completely change the look and feel of things. If you go to the map layer contours, the colors over here are just the boundary colors. So if I change this to this purple, you're going to see that, and let's go ahead, and this has no transparency. So I'm going to increase the width. And you can see that these things, this is the purple that this particular layer controls. So you can go in and completely customize once you've calculated this, how it looks. And that's something that's quite powerful. So I hope you have fun trying out this template. Moving on to the next question. This is again a question that I had from last time, which is basically the difference between a column relation and a column match. So to summarize it in one line, it's basically that your column relations are used to propagate filtering and marking, and your column matches are used to match the tables so that you can use data from multiple tables in the same visualization. So I'm going to show you an example where I have this data table, which is customer table lifetime value that has customer ID, the platform that they are using, and the lifetime value. And I have customer data transactions where I have customer ID with a slightly different names. In the last table, it was cust ID. In this one, it's customer ID. I have the product that they purchased, and I have the amount that they spent on it. Now, here is a standard bar chart showing, what is the lifetime value and how many rows there are for that lifetime value. I'm going to say create a details visualization, and that is also going to be a bar chart. So now when I click on it, you see that because it's basically the same table and it's the same data. But let's go in and change the table that we have to customer data transactions. And now if I select it, even though it has the customer ID in common, it doesn't quite select anything. That happens because right now, Spotfire doesn't understand that these two things are related. So in order to do that, we're going to go to Spotfire, data table properties, customer table, and create a column match with the left column being as cust ID and the right column in the customer data transactions being the customer ID. Say okay, apply, okay. And we have to do it for the other table as well. Similarly, I go to column matches of this table, and this shows up. That's kind of strange. So let me do this again. Oh. So let's do this again. Oops, something's not working right. That should work. My guess is that the marking color is different, so now it's not really considering, like, there's a marking mismatch. But I'm going to go ahead and do the column No, we created a column match. We didn't create a column relation. So my bad. So I'm trying to filter and mark it, but actually I created it such that I can use the same table, use two tables in the same visualization. To show you an example of what I mean by that, right now I have lifetime value from this table. So instead of row count, let's change the table and get the amount from the other table. And now it makes a little bit more sense. So that was just my bad misinterpreting it. Now if I go to data table properties and create a column relation, and I say manage relations, new, the left one is going to be this with customer ID, the right one is going to be this. Again with customer ID, and I click OK, apply. And now if I say create detailed visualization, bar chart, it asks me which table I want. So that's excellent. I can choose any of these two tables because both of them are related now. And you will see that your marking functions as you expect it to function. If I go in and change my data, instead of this table, I use this table. That's just the one that I originally had, and it still works. So that's the difference between customer relations and customer matches. I'm going to not cover this question this time because it will take a little bit more time than what we have right now. Instead, I'll move on to multi-point. This is a simple question around a left join. This is the table that the user has, and this is the second table that they have, and this is what they want. If you just do an insert column and you make sure that you select which column you want to insert, it should work. It's just a very simple process, and these are the steps. You'll have the steps in the video if you want to go back to it. But in the last few minutes, I want to cover this question where the user says that right now, the current behavior is if I select a particular chain. So I have 3 chain restaurants. One of them has 2 divisions, 2 branches, and the other 2 have 1 branch each. So on the map, if I select, a chain, one particular location, the user wants that all the locations of that particular chain should get highlighted. So this is not the current map behavior, and you can't do it using only one visualization. So the workaround that I have is to use 2 visualizations. So you have one visualization with the name or the filter of whichever data point you want to select, whichever institute or chain you want to select, and that controls the marking of the map. So both of these have the same marking. So now what I can do is if I select chain 1, you can see that all the locations get highlighted. Not only that, I can do it backwards. So if I select it here, you see that this one gets highlighted, and then if I click on it, it drives the map. So it's a very nice two-way transaction, and I use it over and over where I have a KPI chart, but I configure a KPI chart just to select my values. And here is a very nice little thing that is often ignored. If you have custom expression, you can give it a display name. So normally, whatever your custom expression is, that's the thing that will show up here. So over here, it would say count or row per ID or something like that. That looks a little bit ugly. So we just give it a display name. It has a nice, clean finish. So thank you, everyone. That was today's session. Make sure you get all the links from the chat. We are hosting a Viz for Social Good hackathon on Wednesday, that is tomorrow in Palo Alto. So if any of you are around, drop in at Tibco. See you next month. Thanks a lot.